Thank you for the opportunity given to us to present our work in this conference. My name is Niluputu Ananda Saraswati. I'm from the Department of Chemistry, Universitas Pendidikan Ganesha. In this next occasion, I would like to present you the current results of our work entitled Absorption of Rimasol Red Dye from Textile Waste Using Activated Carbon from Coconut Shell. I will start with the introduction. The textile industry is currently known to provide the largest contribution to water pollution, far greater than the ink, paper, leather, and printing industries. This is due to the use of various synthetic dye, which will inevitably result in non-biodegradable waste that can pollute the aquatic ecosystem and create a negative impact on human health. One of the most widely used synthetic dye in the textile industry is Rimasol Red. Recently, various effort, techniques, and methods have been developed to reduce the level of this dye in the textile industrial waste. And among them, absorption method is preferred due to its simple procedure with relatively low cost and abundant absorbance availability. In this work, we use coconut shell as a raw materials to produce activated carbon as a natural adsorbent to absorb Rimasol Red solution. So generally, the objective of this research is to study the absorption of Rimasol Red dye solution by activated carbon from coconut shells. This is the experiment designed. We use coconut shells as raw materials and treated the coconut to produce a charcoal powder. There are two types of samples that were studied in this work. The first one is the charcoal powder without activation, and the second one is charcoal powder with activation at 900 Celsius degree. After that, we use the charcoal powder as an absorbent to absorb Rimasol Red solution. And for the data analysis, we have conducted the study of optimum contact time, the study of isotherm adsorption model, and the determination of isotherm adsorption parameters. There are two models that we use to fit the data. The first one is Freundlich model and the second one is Langmuir model. Both of the models' equations are shown in the slide. Let me continue to the results and discussion. The first one is the water content of the charcoals obtained. From the table, we can see that the water content of sample without activation is 22.5%. After activation at 900 Celsius degree, the water content decreased to 9.5%. And this is the charcoals obtained from coconut shell. The second result is the optimum contact time of activated carbon with Rimasol Red solution. The black curve is from the sample without activation, and the red one is a sample with activation at 900 Celsius degree. From these curves, we can conclude that both of the charcoal sample have optimum contact time for Rimasol Red absorption at 30 minutes. Here is 30 minutes. And after this time, the absorption continues to increase, but the increasing of the absorption capacity is not significant after 30 minutes. I continue with the isotherm adsorption model for charcoal without activation and its parameters. The left curves is the result of data fitting using Freundlich model, and the right curve is the result of data fitting using Langmuir model. When we compare these two graphs, we can conclude that the absorption of Rimasol Red dye using charcoal sample without activation follows Langmuir model because the linearity of the graphs using Langmuir model is greater to that fitting using Freundlich model. The same results also obtained from the sample of charcoal with activation at 900 degrees Here you can see from the two graphs, we can also conclude that the absorption of Remasol red dye using charcoal with activation follows Langmuir fitting here with linearity 0.990, and QM is the maximum monolayer capacity for Langmuir, 250 milligram per grams, and KL, Langmuir constant, 0.41. When we do the comparison between the charcoal sample without and with activation, we can see that from some parameters here, the parameters of absorption using Langmuir model, the sample with activation shows greater number compared to that without activation. You see the linearity, the Langmuir constant, and the QM or maximum monolayer capacity are greater compared to that samples without activation. We strongly suggest that this result is due to the activation at 900 degrees was produced a better surface characteristic, and this is also supported by the data of water content. Here you can see from 22% decreased to 9.5%. It means that the sample with activation contain a smallest amount of water, thus form a better surface characteristic that can support the absorption much better than the sample without activation. We conclude, first, the moisture content of charcoals obtained is 22.5% for sample without activation and 9.5% for sample with activation. Second, the absorption isothermal model that is suitable for the absorption of Remasol red dye with activated carbon produced from coconut cell is the Langmuir model, with Langmuir constant value of 0.07 for sample without activation and 0.41 for sample with activation. The optimum contact time for activated carbon with Remasol red dye is 30 minutes. That's all about our presentation. Thank you for your kindest consideration. Thank you and have a nice day.